My name is George. I'm back again. Hopefully, this will be the last time. But I'm here. I'm going to have a little bit of fun with this one. I'm here to explain to the experts why the meteor theory and the meteorite theory that everybody's been following for years is wrong. And I will explain this. Okay, we're going to go down here. They say it's not possible for a whole rock to make it to Earth. Bear with me for a second, and I will show you how. All right, we follow this down here. We use this rock as the Tempel-Tuttle Comet. Okay, these are fragmentations in the comet's trail. Okay, they're going to be traveling at whatever speed this comet is traveling. Okay, follow me so far. Okay. Now, the Tempel-Tuttle Comet, it comes along like this, and it hits any debris in that upper debris field if it is not straight on, like this. If the comet goes by like this and barely nicks the rock, it'll push it into the mesosphere at a slower speed. This debris right here will be traveling at about 133,200 miles an hour. The space debris up here in the debris field travels at 15,700 miles an hour. So if a comet goes like this and nicks just a little bit, just to give it enough nudge, okay, it's going into the mesosphere. How fast do you think it's going into the mesosphere? Not very fast. This is why I believe the people from 1833, what they saw. A bunch of these rocks, when it collided with the debris field, a bunch of these rocks were sent at a slower speed to the mesosphere, and they were traveling at a slower speed to the ground. That would allow the rocks to make it to ground. They wouldn't have burned as much. That's why the rock would look like this. And it would look round because it wasn't going fast through the mesosphere. This is the point that I'm trying to get across to people. There were two types. Two types of meteors. There were the fast ones from the back of the comet, and there were also the ones that were bumped by the comet. And it's simple math and aerodynamics. Any person that's smart can figure this out. Okay, and you can figure this out, okay? But a lot of people aren't piecing this together. Okay, if the meteor is approaching Earth with a slower speed, the rock will likely survive its collision with the Earth's atmosphere. This is what's put out there for everybody. In other words, the meteor will not burn up completely, and some remnant meteorites will fall to the ground. Well, we're basing what we find on fast-moving meteors through the mesosphere. What about slow-moving meteors through the mesosphere? What if it was a super slow shower in 1833 combined with a faster shower because of the debris following the comet is traveling faster than the debris in the debris field? Think about it, okay? The Hoba meteorite, 66 tons, it left no crater. Okay, so that thing wasn't traveling no 133,000 miles an hour. People got to think about this stuff. They say meteors enter the Earth's atmosphere at 133,200, but space debris around the Earth travels 15,700. So what happens if you bump a rock that's going 15,700 miles and you just barely bump it and start heading toward Earth? It's not going to increase to a speed of 133,000 miles an hour. And this is the point I'm trying to get across to people. And if you're an expert out there and you understand what I'm saying, you'll know. You can do the math. But I'm telling you, whole space rocks can make it to Earth if the right circumstances are there. And the pollution in the mesosphere didn't help. Because the slow-moving rocks weren't able to burn with the pollution dropping the mesosphere temperature. And this is what I'm trying to get across to people. Now, you know, people can call me stupid, dumb, whatever they want. They can call me stupid, dumb, whatever they want. But pieces like this that are burnt, they're funky looking, they're totally deformed. This is space debris. This isn't Earth rock. It's space debris. It's smooth on this side. It's smooth all the way around because it got heated. If this was regular Earth rock that broke up, it should be jagged and sharp. What is this? Okay, what kind of rocks are made on Earth like this? And this is the point I'm trying to get across to people. Now, if people want to call me stupid, they want to call me crazy, I'm going off of what all the science and all the data and information that we're given. And I doubt it anybody's ever really given any consider. What if a comet does come around and just bumps a rock a little bit? How fast is it going to make it go? Think about it. Think about it when you're playing pool and you first hit the brake, pow, okay? The balls go everywhere. But when you're trying to hit one into a hole, you barely nick it. It barely moves to go in the hole. Okay, so why would the same thing not happen to space rocks? If there was a collision with them in space, why wouldn't the meteors travel at a much slower speed? It just makes common sense. And that's all I have to say about this.